In our last video, we took these degree measures that were outside of our initial domain from 0 to 2 pi, and we were able to kind of work with them and also find coterminal angles between 0 and 2 pi, as well as negative 2 pi and 0. And we're going to do the same thing in this video, except we're going to be dealing with radial measures, or radian measures, excuse me. And so what we're going to do is we're going to take the radian measure and we're going to draw it in standard position. We're going to convert from radians to degrees. We're going to find a coterminal angle, both in radian and degree measure. And then finally, we're going to find a coterminal angle, this time between negative 2 pi and 0, both in radian and degree measure. It's usually easiest to convert back and forth between radians and degrees. So let's do that first in this example. All right, so that way we can do the standard position a little bit easier. All right, so let's start by taking 13 pi over 6, and we're going to multiply that by 180 degrees over pi. Remember, whatever unit you want to get rid of should go in the denominator. So if we want to get rid of radians, the pi should be in the denominator. Now, at this point, what we can do is we can just multiply 13 times 180 divided by 6, and we're going to do so in our calculator. So 13 times 180 divided by 6, and that gives us 390 degrees. All right, so that just equals 390 degrees. And what we can do now is we can go ahead and plot that in standard position. Right, so here's our graph. Right, we know one complete revolution is 360 degrees. All right, so we're going to take our 390, we're going to subtract 360, and that just leaves us with 30 degrees. All right, so just a little bit more into quadrant 1, and there's our angle. Okay, so this is going to be our 390 degrees for theta. All right, so that's part A. And now we just need to get some coterminal angles. The good news is we've already got one of them. It's 30 degrees, right? Because that's a measure that is between 0 and 2 pi. So for letter C, we have 30 degrees, and we're going to convert that into radians as well. And so we're going to take 30 degrees, we're going to multiply that by pi over 180. And if we go into our calculator, we just take 30 over 180. And that just gives us pi 6. Okay, so that's going to be pi over 6. Right? Last thing we need to do is we need to get an angle that's between negative 2 pi and 0. So that means we just need to subtract 360. So we're going to take 30 degrees. We're going to subtract 360. That's going to give us a negative 330 degrees. Okay, if we don't trust it, we can always use our calculators. And then we're going to take that negative 330. Oh, not 333, negative 330, excuse me. And we're going to multiply that by pi over 180 degrees, all right? And if we do so, that should be a negative 11 pi 6, but let's just make sure. All right, so we're going to have our 300, let me go back here. We have negative 330 over 180. So negative 330 over 180, and that gives us negative 11 pi 6. All right, if we want to put it into decimal mode, there you go. Okay, so that's going to be our negative 11 pi over 6. All right, so that's pretty easy. Okay, again, all we're doing is we're just using our factors and multiples of 360 to be able to multiply or I'm sorry, to subtract and also add. Okay. All right, one last example here. We have negative 22 pi thirds. All right, so once again, let's start with letter B, and let's convert this into degrees, so that way what we can do is we can plot this. All right, so we're going to take our negative 22 pi over 3, and we're going to multiply that by 180 over pi. All right, pi's cancel out, and then we just go into our calculator. All right, and we take 22 times 180, and we divide that by 3, I think it was. Let me go back. So yeah, 22 thirds times 180. All right, and if we do that, that gives us 1320. All right, so this is a pretty small angle. So negative 1320 degrees. All right, now what we're going to have to do is we're just going to have to continuously add 360 to be able to plot this in standard position. All right, so now remember, it's a negative angle. So we're going to start here, and we're going to go around once. All right, so pardon me, it's not really a good circular angle. All right, so go around once. All right, and that gives us our 360. Okay, and remember what we're doing is we're going clockwise this time instead of counterclockwise. So we have negative 1320 plus 360. All right, and that's going to give us 960 negative. Then we're going to add another 360 to that, and that should give us 600 degrees negative. All right, so just add another 360 negative. All right, so that's another one. Actually, let me draw a better representation of this, and maybe a little closer to the axis might be helpful. So this is once, this is twice. Okay, we're going to add another 360 to that. And if we do so, that's going to give us a negative 240 degrees left over. Okay, so this is another revolution. All right, so that's 3 revolutions. Okay, so 1, 2, 3. And then finally, we just need negative 240. If we take another 180 out of that, okay, so we're just going to add another 180. All right, so it's a little bit torturous, but could be a lot worse. Okay, that's going to leave us with negative 60 degrees. So now all we have to do is just draw 60 more degrees. That's about right here. And this should be our angle. Okay, so this is going to be theta equals negative 1320. Okay, or in radian measure, negative 22 pi thirds. All right, so that one was kind of tough because we had to go through and do a lot of work for this. Okay, but the good news is, all right, that we can pretty easily get some coterminal angles for this. Okay, so for letter C, actually letter D is a little bit easier. We want to find a coterminal angle between negative 2 pi and 0, right? And so we already know that this angle right here, negative 240, is a coterminal angle because we added 360, added 360, added 360, and we ended up at negative 240. So for letter D, we already have negative 240 degrees. And then we're going to convert that into radians by multiplying by pi over 180. All right. And so once again, our calculator, we're just going to take our 240 divide 180. All right, and that's going to give us 4 pi thirds. And that's going to be a negative. That's negative 4 pi over 3. Now for letter C, we had that negative 240, and what we can do is we can add a 360 to that. All right, and that's just going to leave us with 120 degrees. Right. So again, all we're doing is we're just taking these multiples of 360, and we just keep adding and adding and adding. Okay, until we get to a measure that we need. Right. Then we're going to take the 120. We're going to multiply by pi over 180. All right. And that should leave us with 2 pi thirds, but we just want to check just to make sure. So we take our 120, divide 180. We hit math, enter, enter. We have 2 pi thirds. All right, so that's going to be 2 pi over 3. And that's certainly going to be an angle between 0 and 2 pi. All right, so again, that's how we deal with some of these larger angles, okay, or very small angles, okay? All right, so that's going to be it for angles in this section for a little bit. The last things we're going to look at is we're going to revisit arc length of a circle, and then we're also going to take a look at angular and linear velocities, and that'll be it for this section.